Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, let us see the questions 21 to 40 of the November 2020 Electronic Science question paper. 21st question. The program written below gives move A, number 85H, CPL add A, number. Option A 7BH, option B B7H, option C 78H, option D none of the above. The first instruction, move A, number 85H, stores the binary equivalent of the number 85, that is 1000101 in the accumulator. The next instruction, CPLA, complements each bit of the number stored in the accumulator and stores the result again in the accumulator. The next instruction, add A, number, adds both the number 85H and its complement and stores the result in the accumulator. So the end result in the accumulator will be FFH. Hence option D, none of the above, is the correct answer. Next question, the relationship between revolution per minute RPM, steps per revolution SPR and steps per second SPS is given by A. SPS is equal to RPM into SPR by 60, B. RPM is equal to 60 divided by SPS into SPR, C. RPM is equal to SPS into SPR divided by 60, D. SPS is equal to 60 by RPM into SPR. Here if you see RPS, that is revolution per second, is equal to RPM by 60, revolution per minute by 60. Now steps per second is equal to steps per revolution into revolution per steps. Hence steps per second is equal to steps per revolution into RPS is nothing but RPM divided by 60. So option A is correct. What happens if interrupts INT0, TF0 and INT1 are activated at the same time? Option A, they are latched and kept internally. Option B, they are latched and kept externally. Option C, they are unlatched and kept internally. Option D, they are unlatched and kept externally. Here if you see, when these interrupts are activated at the same time, they are latched and kept internally. So option A is correct. Next question, in the register indirect addressing mode, the effective address of the datum in the base register or an index register that is specified by the instruction is option A, EA is equal to AX DI SI, option B, EA is equal to BX DI SI, option C, EA is equal to CX DI SI, option D, EA is equal to DX DI SA. In register indirect addressing mode, the operand's offset is placed in any one of the registers, that is BX, BP, SI and DI as specified in the instruction. The effective address of the data is in the base register or an index register that is specified by the instruction. So option B is correct. Next question, RG59U type transmission line has an open circuit impedance of 150 angle 25 degree ohm and a short circuit impedance of 37.5 angle minus 35 degree ohm. The value of characteristic impedance is given by. Here if you see, the formula for characteristic impedance is given by Z0 is equal to square root of ZOC into ZSC. ZOC is the open circuited impedance and ZSC is the short circuited impedance. So substituting for ZOC as 150 angle 25 degree and ZSC as 37.5 angle minus 35 degree, we have Z0 is equal to square root of 5625, which is the product of magnitudes, that is 150 into 37.5, and angle, which is the sum of the arguments, 25 minus 35 degree, which is minus 10 degree. If you take square root, the square root of 5625 is equal to 75, and square root of angle is nothing but half of the angle, which is equal to minus 5 degree. So the characteristic impedance is Z0 is equal to 75 angle minus 5 degree ohm. So option B is correct. Next question. An air-filled rectangular waveguide of dimension 7 into 3.5 centimeter square operates in the dominant TE10 mode. The value of phase velocity of the wave in the guide at a frequency of 3.5 GHz is given by option A 3.78 into 10 to the power 8 meter per second, option B 6.78 into 10 to the power 5 meter per second, option C 5.78 into 10 to the power 8 meter per second, option D 4.78 into 10 to the power 8 meter per second. Here option A is correct. Let us see the solution. For TE10 mode, that is transverse electric mode, the cutoff frequency is given by Fc is equal to C by 2 into E. C is nothing but velocity of wave, which is equal to velocity of light. So C is equal to 3 into 10 to the power 8 meter per second, and A is the dimension of the rectangular waveguide, that is length of the rectangular waveguide. So substituting for A as 7 centimeter, we have the cutoff frequency Fc is equal to 2.14 GHz. The phase velocity of the wave in the guide is given by Vp is equal to 3 into 10 to the power 8 divided by square root of 1 minus Fc by F the whole square. Here they have given the frequency as 3.5 GHz, and we found the value of cutoff frequency as 2.14 GHz. So substituting in the formula, we get the phase velocity as Vp is equal to 3.79 into 10 to the power 8 meter per second. Next question. In case of linear arrays of n isotropic point sources of equal amplitude and spacings, the expression for total electric field at a large distance in the direction theta is given by. The expression for total electric field is given by the formula E is equal to 1 minus e power j n psi divided by 1 minus e power j psi. So option D is correct. Next question. A sphere of radius r1 is equal to 30 centimeter has a charge density rho into r by r1, where rho naught is equal to 200 picocoulomb per meter cube. The value of total charge on the sphere is given by option A 34 picocoulomb, option B 8.5 picocoulomb, option C 17 picocoulomb, option D 68 picocoulomb. Here the answer is option C 17 picocoulomb. Let us see the solution. According to Gauss law, we have the charge enclosed by the sphere is equal to integral of, that is volume integral of rho v into dv. Rho v is the volume charge density. This can be expressed in terms of polar coordinates as q is equal to integral of 0 to 2 pi integral of 0 to pi integral of 0 to r1 rho into r divided by r1, which is the volume charge density they have given, into r square into sin theta dr d theta d phi. Taking the constant terms outside, that is rho naught by r1, we have integral of 0 to 2 pi 0 to pi 0 to r1 r cube sin theta dr d theta d phi. So integrating this, we have rho naught by r1 integral of r cube is equal to r to the power 4 by 4 limits 0 to r1 integral of sin theta d theta is equal to minus cos theta limits 0 to pi integral of d phi is equal to phi, limits 0 to 2 phi. Now minus cos phi is equal to minus 1. So minus of minus 1 is equal to, now substituting the limits, that is upper limit minus lower limit, minus cos phi minus cos 0, which is equal to 2, and substituting the limit for phi is equal to 2 pi. So we have q is equal to rho naught by r1 into r1 to the power 4 divided by 4 into 2 into 2 pi. Now simplifying, we have q is equal to pi into rho naught into r1 cube. Substituting the value of rho naught is equal to 200 into 10 to the power minus 12, since they are given picocoulomb per meter cube, and r1 is equal to 30 into 10 to the power minus 2 the whole cube, since they are given meter. We have the value of q is equal to 16.96 into 10 to the power minus 12. The total charge on the sphere is q is equal to 17 picocoulomb. Next question, a VSB transmitter, that is vestigial sideband transmitter, that transmits 25% of the other sideband along with 1/3 sideband radiates 0.625 kilowatt when the modulation percentage is 60%. If we want to transmit the same message by an AM transmitter, then carrier power in kilowatt required is. Here if you see, the vestigial sideband power is related to carrier power as PVSB is equal to mu square by 4 into PC plus F into mu square by 4 into PC. Here mu is the modulation index and F is the fraction of power transmitter. Taking mu square by 4 into PC as common, we have 1 plus F. Substituting the value of VSB power as 0.625, modulation index as 0.6, fraction of power transmitter as 0.25, we have the carrier power PC is equal to 5.56 kilowatt. So option B is correct. Next question, the term dispersion describe the process of option A, reflecting light from a smooth surface, option B, the process by which light is absorbed by an uneven rough surface, option C, light scattering, option D, separating light into its component frequencies. Dispersion of light is the splitting of white light into its constituent colors due to the refractive index of the surface and the wavelength of the light. Hence option D, separating light into its component frequencies, is the correct answer. Next question, in a frequency division multiplexing system, 10 channels are multiplexed, each channel having a bandwidth of 50 kHz. If the guard band between the channels are 1 kHz, the minimum bandwidth required for transmission is option A 505 kHz, option B 500 kHz, option C 509 kHz, option D 510 kHz. Here if you see, the minimum bandwidth required for transmission is given by the formula n into bandwidth of channel, n is the number of channels, plus n minus 1 into guard band. Since the guard band is provided in between the channels to avoid interference. Substituting n is equal to 10, bandwidth of channel as 50, n minus 1 is equal to 9, and guard band is equal to 1 kHz, we have the bandwidth is equal to 500 plus 9, which is equal to 509 kHz. Hence option C is correct. Next question, the main objective of cell in a cellular mobile system is option A higher bandwidth, option B handoff, option C frequency reuse, option D symbol modulation techniques. Frequency reuse is the main objective of cell in a cellular mobile system. Hence option C is correct. Next question, in the following circuit, beta is in the range of 8 to 40, RC is equal to 11 ohm, VCC is equal to 200 volt, RB is equal to 10 ohm. If the VCE saturation is equal to 1 volt and VBE saturation is equal to 1.5 volt, overdrive factor is equal to 5, the value of power loss in the transistor is given by A 35.07 watt, B 23.07 watt, C 13.07 watt, D 26.09 watt. Here option A 35.07 watt is the correct answer. Let us see the solution. In this question, VBE saturation is equal to 1.5 volt and VCE saturation is equal to 1 volt. So, VBE saturation is greater than VCE saturation. Hence, the transistor is operating in saturation region. Now, the saturation collector current is given by the formula ICS is equal to VCC minus VCE saturation divided by RC. VCC they have given as 200 minus VCE saturation is equal to 1 volt divided by RC is equal to 11 ohm. So substituting we have ICS is equal to 18.09 amps. The base current is given by the formula IB is equal to IBS, that is base current saturation, into overdrive factor. IBS is nothing but ICS divided by beta into ODF. Substituting ICS is equal to 18.09 and beta is equal to 8 and overdrive factor is equal to 5, we have IB is equal to 11.31 amps. Now the power loss can be found by using the formula PE is equal to VBE into IB plus VCE into IC. VBE is equal to 1.5, IB is equal to 11.31, VCE is equal to 1 and IC is equal to 18.09. Substituting these values, we have the power loss as 35.06 watts. Next question. A 3-phase 4-pole induction motor is operating on an input frequency of 75 Hz and slip of 4%. The rotor resistance of the machine is 1 ohm. The torque developed by the motor is given by, assuming the operating voltage is 415 volt, assuming stator voltage drop is equal to 0. Option A 6889 synchronous watts, option B 7898 synchronous watts, option C 8998 synchronous watts, option D 9998 synchronous watts. Here option A is correct. Let us see the solution. In the question they have given frequency is equal to 75 Hz, slip is equal to 4%, number of poles is equal to 4, rotor resistance is equal to 1 ohm, E2 that is operating voltage is equal to 415 volt and X2 is equal to 0, that is rotor reactance is equal to 0 ohm. Now the synchronous speed can be found by using the formula 120 F by P. F is equal to 75 Hz and P is equal to 4. Substituting we has the synchronous speed Ns as 2250 rpm. Under running condition of induction motor, the torque per phase is given by the formula Tr is equal to S into E2 square into R2 divided by R2 square plus S into X2 the whole square. S is the slip, R2 is the rotor resistance and X2 is the rotor reactance. Substituting slip as 0.04, E2 as 415 and R2 as 1 ohm and X2 is equal to 0, we have the torque as 6889 synchronous watts. Next question. Insertion of negative feedback in control system affects option A, the transient response to vanish uniformly, option B, the transient response to decay very fast, option C, no change in transient response, option D, the transient response decays at a slow rate. Here if you see, inserting negative feedback in the system, the transient response will decay very fast. So option B is correct. Next question. For the following first order system, the value of steady state error for unit ramp input is given by Option A 0, option B infinity, option C 1 minus e to the power minus t by t, option D 1 plus e to the power minus t by t. Here answer B is correct. Let us see the solution. The steady state error is given by the formula ESS is equal to limit s tending to 0 s into R of s divided by 1 plus d of s into h of s. They have given R of s, that is the input, as unit ramp, which is equal to 1 by s square, and g of s is equal to 1 by s into t. It is a unity feedback system, so h of s is equal to 1. Now ESS is equal to limit s tending to 0 1 by s divided by s into t plus 1 divided by st. Simplifying, we have ESS equal to limit s tending to 0 t divided by s into t plus 1. Substituting s is equal to 0, we have the steady state error as infinity. Next question. A dual slope integrating type of analog to digital converter has an integrating capacitor of 0.1 microfarad and a resistance of 100 kilo ohm. If the reference voltage is 2 volt and the output of the integrator is not to exceed 10 volt, the value of maximum time the reference voltage can be integrated is option A 10 millisecond, option B 50 millisecond, option C 50 microsecond, option D 10 microsecond. Here answer B is correct. Let us see the solution. They are given capacitor value as 0.1 microfarad, resistor is equal to 100 kilo ohm, reference voltage is equal to 2 volt, maximum output voltage is equal to 10 volt. The formula for maximum output voltage is given as V0 max is equal to reference voltage into time divided by RC. So time is equal to RC into output voltage maximum value divided by reference voltage. Substituting R as 100 into 10 to the power 3, capacitance is equal to 0.1 into 10 to the power minus 6, and V0 max is equal to 10 and V reference is equal to 2, we have the time is equal to 50 millisecond. That is, the value of maximum time the reference voltage can be integrated is 50 millisecond. Next question. The velocity transducer consists of a moving coil suspended in the magnetic field of a permanent magnet. It is not used for measurement of velocities developed in a option A linear manner, option B sinusoidal manner, option C both A and B, option D discrete manner. Here if you see, the velocity transducer is not used for measurement of velocities developed in a discrete manner. So option D is correct. Next question. What is not the source of error in a thermocouple transducer? Option A open junction, option B thermal conduction, option C galvanic action, option D Hall effect. Here Hall effect is not the source of error in a thermocouple transducer. So option D is correct. Next question. Which is not the important characteristics of thermistors that make them extremely useful in measurement and control applications? Option A the resistance temperature characteristics, option B the voltage current characteristics, option C the current time characteristics, option D the power time characteristics. Here the power time characteristics is not the important characteristics in thermistor, all the other characteristics are important. So option D is correct. Thanks for watching the video. For more videos, don't forget to subscribe our channel.